Today we're going to talk about the devastating social and economic impacts of the 8.8 magnitude Chilean earthquake on the 27th of February 2010, and how civil engineering can help develop solutions to address these problems. An earthquake is the perceptible shaking of the Earth's crust due to the shifting of tectonic plates. During an earthquake, public infrastructure is greatly affected, which is why we need civil engineers to design and build safer structures. Buildings collapse during an earthquake due to the lateral loads imposed on the buildings by seismic waves. Structures undergo cyclic loadings to the point where it fails. Poor boundary detailings caused the O'Higgins Tower to collapse, such as weakly reinforced walls. All the vertical reinforcements in the walls deformed largely and failed. One of the solutions is that structural engineers could introduce diagonal bracings and dampers to buildings. Bracing and dampers provide a structure with larger lateral resistance and decreases the amplitude for structural vibrations. During an earthquake, many roads and highways and bridges become unusable, be it due to cracks, collapses, or floods. These were the result of improper soil compaction leading to liquefaction, which is a phenomenon where saturated soil loses its strength and stiffness, thus acts like a fluid under these forces. As a result, delays in logistic companies occur, education and work are halted, productivity lost, and resources are spent. In these cases, short-term alternative routes should be set up immediately. Engineers should also survey the soils on the site beforehand and carry out preventive measures accordingly, such as granular soil compaction to prevent liquefaction. Another aspect to consider during an earthquake is the evacuation plan for large public spaces such as sports venues and stadiums. The National Stadium of Chile has a capacity of more than 48,000 people, which is potentially dangerous in the case of an earthquake. Important aspects of evacuation include crowd control measures, accurate signage, and safe zones that can accommodate the whole crowd. The Las Palmas tailings dam is a deposit for copper ore residue. When the earthquake in Chile occurred, due to liquefaction of the soil, there was a landslide of tailings traveling 500 meters. This incident caused the soil to get contaminated and triggered a great economic loss for the copper mining industry. To prevent the landslide from happening, civil engineers should lower the inclination of the dam's slope such that it is far less than the friction angle, which is the maximum inclination that a stable slope can have. In conclusion, the 2010 Chile earthquake caused significant financial loss and many casualties. Hence, it is crucial for an engineer to place great importance in considering safety margins for their designs. Also, the Chilean government should support better engineers who possess the power to push boundaries of people's desire for monumental yet safe structures.